So we're working our way through Chapter 7, and in Lesson 7.4 we've been starting to work with quotients of powers. So you already learned that if you're going to compute the quotient of powers with like bases, that you subtract the exponents. Today we're going to take a look at powers of quotients. And just like we do with the other properties, we're going to start by writing out what this actually means. So we've got this thing here, x to the fourth over m squared, that we're going to raise to the third power. And so we know that that means we're going to write that x to the fourth over m squared down 3 times and multiply those together. And since we know how to multiply fractions, we're going to multiply these numerators together. That'd be x to the fourth times x to the fourth times x to the fourth. And we're going to multiply these denominators together. M squared times m squared times m squared. And since we know rules for multiplying powers with like bases, we will simply add these exponents on top, and we'll end up with x to the 12th. And on the bottom, we'll end up with m to the 6th. And just like all of our other rules, what we're trying to do is figure out how to avoid all this math in the middle here. Basically, we're looking for a shortcut. We don't like to admit that we're a little lazy, so we say we're trying to be efficient and practical and quick, but that's what we're doing. And just like with the power of a product, what we realize is all we really did is apply this power to the numerator and to the denominator. Right? We did a power on a power for x to the fourth to the third power. We multiply 3 and 4 together and we get 12. We did a power on a power for m squared to the third power. 3 times 2 is 6. We get m to the 6th. So we discover, just by writing out what this means, that we've got this new rule which says we just apply that power on the outside, the 3, to the numerator and the denominator separately. And we follow the same rules we had before. So that's the deal. We're just going to sort of like distribute that 3 to the numerator and the denominator, multiplying the exponents. We won't multiply the bases. Okay, so I'm going to pause for a second and make sure you have this written down, because just like our other videos, you want to add these examples to your notes. And at the end, we're actually going to practice all of our rules. That's our goal for today, to practice all these rules that we've had, these properties of powers. Well, that's enough stalling. Let's do a couple more examples. So now that we have this new tool, we're going to try and use it to find some powers of quotients. So we're going to apply this third power to the numerator. And since it's a product, we'll have to use the power of a product rule, which means we have to apply that power to both of the factors. Please remember this a has a hidden exponent of 1. And we'll also apply this power to the denominator. And we'll follow our shortcut. We're not going to write all that math out. And lo and behold, we get a to the third power, because 3 times 1 is 3. B to the 6th power, 3 times 2 is 6th, over x to the 9th power, because 3 times 3 is 9. And there you have it. We follow this power of a quotient rule. We apply the exponent of 3 to all the factors in the numerator, and then to the power in the denominator. And we get a cubed, b to the 6th, all over x to the 9th. And just like the other problems that we've worked with products or with quotients, we start to introduce coefficients, like this 2 right here, right? And we just need to be careful how we apply this exponent to that 2. Because the 2 acts like a base, remember, there is an exponent of 1 on the 2. So when we apply this power, it's kind of like distributing, we're going to apply it to 3 times 1. We're going to apply the 3 to the first power. We'll apply it here, 3 times 4. Same thing on the bottom, the z has a 1. So we'll apply it there, 3 times 1, and also to the x squared, so that'll be a 3 times 2. So here's what I see that we end up with. We end up with 2 cubed m to the 12th in the numerator, x to the 6th z cubed in the denominator. And if you want to go for the a plus answer, 2 cubed is an easy power to evaluate. So we'll go ahead and make that an 8. The number one mistake that our younger learners make when they first start to do, quizzes and tests on these things is they make that a 6. They do 2 times 3 is 6. Please avoid that. It means 2 times 2 times 2, not 2 times 3. Okay, so there's the result of that power of a quotient. I'm going to stall here for a minute while you get this in your notes, especially since one of these in the video is probably on the worksheet that I'm going to have you practice. I should mention that the reason we're studying these properties of these powers is we're trying to get to a point where we can work with something called polynomials, and that's in the second half of Chapter 7. Once we figure out how to work with polynomials, we can move on to quadratic functions, and it's going to get really, really, really awesome and fun. Just remember I said that in a couple weeks when you're angry with me. So what we've been using is formally called the positive power of a quotient property, and it's outlined in your textbook. You can see there's a verbal model here. Quotient raised to a positive power equals the quotient of each base raised to the power. You can see there's an example here, which is basically what we did in the previous slide. And we just apply the 4 to the top and the bottom, and we're good to go. And then there's also an example where everything's a variable. The bases are variables and the exponent's a variable. And so you can refer to this if you happen to forget what we're working on. And this goes along with examples 2 and 3 in Lesson 7.4. Now, right after the positive power property, there's also a negative power property. And I'm going to show you that right now, and we'll see if we can make sense of that before I do the examples. So here's that negative power property. And there's a funny thing that I want you to notice right here in the middle. If we raise a quotient to a negative power, that's like raising the reciprocal to the positive power, right? This says 2/3, this says 3/2, 3 over 2. And that's because when you divide by a fraction, you actually multiply by the reciprocal. So remember that we know that when we raise something to a negative power, that's actually 1 over that thing raised to the positive power. Well, this is called the reciprocal, as you know. And the reciprocal of a fraction is just flipping the fraction over. So that's why in the middle here, those things are flipped over. And it's actually true here too. All you do is flip the fraction over and do the positive exponent. And that's exactly what we just went over, so it's really not that bad. Just wanted to point that out to you before we went through this process. So we're going to flip over the fraction and do the positive exponent. Let's give that a shot. So you look at this problem, and it looks a little complicated, but remember what we said was we're going to flip over the fraction and do the positive exponent. And so that's what I'm going to write down right now, starting by just rewriting this thing. Oh my goodness. Boop. That'll be in the blooper reel. We're going to flip the fraction over. So this is y cubed over 2x squared. Wow, that's a 2 with a long nose. And remember, we're going to make it a positive exponent. Once you get it to here, it's exactly what we've been practicing in the other examples. Apply the power on the numerator. Goodness gracious, I got to stop bumping the bottom of this thing. My excuse is that it's late. But excuses, aren't really worth much. Apply the power on top, so we're going to multiply those exponents. Apply the power to the x squared, we're going to multiply those exponents. And remember there's a little 1 here, and we're going to apply the power to that one. And so it looks like this is going to end up being y to the 6th, because 3 times 2 is 6. 6. 2 squared, because 2 times 1 is 2. And x to the 4th, because 2 times 2 is 4. And speaking of 2 times 2 being 4, this is a really easy power right here, 2 squared, to evaluate. Man, I'm having that. My pinky finger keeps getting in the way here. Okay, 2 squared, that's 4, so let's clean that up a little bit. Y to the 6th over 4x to the 4th. So flip over the fraction, change the exponent to positive, and then do the exact same property that we had before. Okay, so what does all this mean? I'm showing you all this stuff because today our goal is to practice all of our rules. So you're about to receive a handout that looks kind of like this. And there's going to be columns. I've just shown you the first row, but this thing continues down. So there's columns all the way down the page where you're just practicing these properties. So the first property that we're going to practice is simply the product of powers. And in case you've forgotten, when you have powers with like bases, you simply add the exponents if you want the product. So I'm just going to make a note here that we add. So that's x to the 10th. The next thing we're going to practice is the power of a power. And in case you've forgotten, here we're going to multiply the exponents. So this is x to the 12th. How do you spell multiply? It's not mut. We'll put mult, period. Quotient of powers. Remember the rule here is to subtract the exponents if they have like bases. So 5 minus 2 is 3. So I'm going to write x cubed in there. Just remind yourself this is subtract. Power of a product. We're going to apply that power to each factor. So this is m to the 4th, n to the 4th. It's kind of like distributing, so I'm just going to draw these arrows here telling us to... Oh, those arrows are terrible. Terrible, terrible. Let's try. That's my way of telling you to pass that 4 out to every factor. Same thing with the quotient, power of a quotient that we just learned. This is going to be m to the 4th over n to the 4th. We're just passing out or distributing that exponent to each base. And you're just going to work your way down the page there. Okay, that's our goal. So we're adding exponents in the first column, multiplying in the second column, subtracting in the third column, sort of like distributing in the fourth column, and sort of like distributing in the fifth column. As you work your way down the page, they're going to get slightly more complicated. But our goal here really is just to reinforce these rules, because eventually what's going to happen is we're going to mix them up. Okay, I think you've heard enough from me. So let's get down to business and we'll work through these, and then we'll pick up the second part of our lesson. Good luck.